Good morning, everybody. Today we are going to be dealing with measures of central tendency, and I want us to move very, very fast. Nevertheless, not leaving away understanding. Is it clear? So let us start with a simple story. So we are still in STA 111, okay? Introductory statistics as I know it. Introductory statistics. I want everybody's attention to be top class today. Measures of central tendency. So we are going to begin with a small story as to how best one can describe what is called a measure of central tendency. I hope everybody is listening. Now, the first question we have to answer that I'm going to write on the board eventually is what is a measure of central tendency? Okay? So after answering that question, what is a measure of central tendency, we would now go into, what do you call it? Types of measures of central tendency. Now, before we write on the board, let's begin with my explanation. Okay? To show you that consciously or unconsciously, we have been using measures of central tendency. So, let's start this way. I don't know how Daniel became your representative, but I am sure it could have been by appointment, it could have been by election. Do you understand me? If it is by appointment, one thing is for sure, and if it is by selection or election, one thing is also sure. The function of Daniel to the class, in the class, is to represent everybody in this class. Am I right or wrong? Now, if you move away from the class, having a class rep who represents you, the word class rep means class representative, is it not so? What do you think a governor does? When we go out to the polls to elect who would be our governor out of a list of candidates, it is everybody going out to make a choice of one that will be elected as our governor. And again, the reason for electing him as our governor is so as to represent what? The entire state. Is it not so? At federal level, whatsoever our governor says to the presidency is what the presidency takes as the voice of the people, so to say. In any local government, we will choose or elect a local government chairman to also represent. In our homes, by default setting, it could be possibly that your father is the House representative, so that anybody that wants to deal with you would want to speak with your father. Is it not so? It could also be your mom if you were trained by a single parent, such as your mom. It could also be your mom heading the house. Okay? So it is not out of place for that to happen. Now, in any case, whoever is produced in this instance, whether by election or by selection or by choice, is called the class rep, as it were, the governor, the president, and they all are to do but one thing: to represent an entire group of people. Is it clear? Now, what then is a measure of central tendency? A measure of central tendency can be compared to an electoral process. A measure of central tendency can be compared to a selection process. And it will do one thing, just like the electoral process or selection process. It will produce for us a representative value, just like a governor, a class rep, a president. that will represent the entire class. Is it clear? So, that being said, let us now see. Let's start with answering that question. What is a measure? What is a measure of what? Central tendency. What's a measure of central tendency? So we say a measure of central tendency, a measure of central tendency, a measure of central tendency is, first of all, a statistical measure. Okay? It is first of all what? A statistical measure. Now, please take note of one thing. Please take note of one thing. When we say it is a statistical measure, the definition does not stop there. That is simply because it is not the only statistical measure. A measure of central tendency is a statistical measure. A measure of dispersion is a statistical measure. A measure of skewness and kurtosis is also what? A statistical measure. So what differentiates a measure of central tendency from a measure of dispersion? What differentiates a measure of dispersion from a measure of skewness and kurtosis? That is what makes a measure of central tendency unique. So when we say a measure of central tendency is a statistical measure, the definition is not complete. It is a statistical measure that produces a representative value. A representative value for a data set. Full stop. Okay, so please, I hope everybody understands. Number one question is, what is a measure of central tendency? Number one, everybody should know that a measure of central tendency is a statistical what? Measure. Is it clear? But the fact is, even as it is a statistical measure, it is not the only statistical measure. Is it clear? So, question is, what makes it as a statistical measure different from every other measure? What makes it different is the fact that it is the statistical measure that will produce what? A representative value for a data set. Is it clear? That is the reason why I said earlier on that a measure of central tendency is like the electoral process. So the value it produces is not the measure of central tendency. So the governor is not the measure of central tendency. The electoral process that produces the governor is the measure of central tendency. Am I talking to somebody? The voting process that produces a class rep is the measure of central tendency, but the class rep is not the measure of central tendency. The class rep is the value that was produced by what? That measure of central tendency, which in this case is the voting process. Is it clear? For instance, an electoral process that produces a governor, president, class rep, etc., can be likened to a measure of what? A measure of central tendency. Full stop. Next, types of measures of central tendency. Types of measures of central tendency. Types of measures of central tendency. There are several measures of central tendency. Some of them are: 1, the mean; 2, the median; 3, the mode; 4, the quartiles; 5, deciles; 6, percentiles, etc. So we are certainly going to take more than that. Is it clear? Great. So there are several measures of central tendency. Some of them are the mean, the median, the mode, the quartiles, the deciles, the percentiles, and even more. So we are going to start our discussion under measures of central tendency. We are going to start with the mean. Is it clear? So when we say the mean, students often think that the mean is just the arithmetic mean, or the mean is just the average. There are several types of means. So we are going to consider the following. The mean is a way of averaging. Let me rather put it as, the mean is a measure, is a statistical measure, that averages the data entries in a data set through different methods. Okay? So what we call the mean is a statistical measure of central tendency, of course, that averages the data entries in a data set through different methods. And because of the different methods of doing that averaging, we now have types of means. So, for this reason, there are several types of means. Namely, for this reason, there are several types of means. Namely, 1, what are we trying to say? What we are trying to say in essence is that don't think that the mean is just the arithmetic mean. So the arithmetic mean is just one type of what? It's just one type of what? Mean, right? So 2, we have what we call the weighted mean. The weighted mean. The weighted mean is another type of mean. Number 3, we have another type of mean we call the harmonic mean. The harmonic mean. Number 4, we have another type of mean we call the geometric mean. The geometric mean. Number 5, we have another type of mean we call the grand mean. The grand mean. So, now, what did we say? There are several types of measures of central tendency. We are going to consider these ones and maybe 2 or 3 more. But now that we are under types of measures of central tendency, we are now starting with which one? We are starting with which one? The mean. And now that we are also going into the mean, we started with telling ourselves what the mean is. That the mean is a statistical measure of central tendency that averages all the data entries in a data set through different what? Methods. So the question is, if there are different methods for doing that averaging that the mean does, shouldn't there be different types of what? Means? So because of that there are different methods for doing the averaging, it now prompts different types of what? Mean. And the first mean we shall be looking at, everybody, is arithmetic mean. The weighted mean is another type of mean. When you calculate your CGPA, what do you think is used in calculating CGPA and GPA? What we use in statistics for calculating your CGPA is called the weighted mean. And I'm going to explain the difference between the weighted mean and the what? The arithmetic mean. Is it clear? The harmonic mean is another type of mean. The geometric mean is another type of mean. The grand mean is another type of mean. So don't think that the mean only refers to what? The arithmetic mean. That being said, I want to go over there and start with what? The arithmetic mean. Is it clear, everybody? Good. We are now in arithmetic mean. So when we are done discussing all these types of means, where would we now be going to? The median. Is it not so? As a measure of central tendency. So let's quickly look at this. Now, the arithmetic mean is a type of mean that can be computed for one, data entries without frequencies. Let me put it this way. For one, case one, ungrouped data entries without what? Frequencies. There are three cases we are going to consider now. If you want to compute the arithmetic mean, know that it can be computed for a data set that contains data entries without what? Frequency. Is it clear? Two, it can be computed for ungrouped data. This should be data set, please. Ungrouped data set without what? Frequency. Ungrouped data set with what? Frequencies. Then three, it can be computed for grouped data sets. Now, I'm not putting with or without frequency because if it is a group data set, it certainly should have what? Frequencies. Is it clear? Now, let's start with case I. Case I now is when you want to compute the arithmetic mean for an ungrouped data set without frequencies. What will be the formula? So I'm going to say for case I, ungrouped, I'm going to put here arithmetic mean for ungrouped data set without frequencies. So let's start with this first case. Okay, so we are starting with this first case. Now I'm going to say let x1, x2, x3 up to xn be data entries in a data set. Full stop. The arithmetic mean of the small n data entries, that is the arithmetic mean of the n data entries. Look at them, everybody. If you have x1, x2, x3 up to xn, it means that you have n of them. Is it not so? You have n of them. So if you have x1, x2 to xn data entries in a data set, if you want to get the arithmetic mean of this data set, what would you do? It will mean that you are looking for the average of all the n data entries. So we are saying the arithmetic mean of the n data entries denoted by x bar. We use x bar. When you see us write x with a bar on top, we are referring to what? Arithmetic mean. Is it clear, everybody? Once you see x bar, you see y bar, you see z bar, it means you are referring to what? The arithmetic mean. Is it clear? So I am saying the arithmetic mean of the n data entries denoted by x bar is given by the formula x bar equals, read this for me, everybody. Read that for me. Read that formula for me. Then please take note, your equal to should be on the divide, that dividing line. Don't write like this, please. X bar equals, you now put this over n, or you put this. Your line should be on that equal to. Is it clear? So please read this statement for me. X bar is equal to what? You see, when I was showing you that thing in that other class and telling you how to read it, some of us were thinking it was a joke. In this particular class going forward, we'll be using this and you'll be reading it almost every day. I told you that this whole thing is a shorthand notation for adding x1 to x2 to x3 up to what? Xn. So this is read as the summation of all this sigma here means summation. So this thing is read as the summation of all xi's starting from I equals 1 to I equals n divided by n. So what is x bar for an ungrouped frequency without what? For an ungrouped data set without frequency? The formula for x bar will be what? The summation of all xi's in that data set starting from when I equals 1 to n divided by what? N. Now, I want us to take all our examples at once. So let us take everything that we have to write down at once, then take our example when we are done with that. Is it okay? So, case 2. Case 2 is ungrouped arithmetic mean. Arithmetic mean for ungrouped data set. Ungrouped data set with frequencies. Ungrouped data set with frequencies. Ungrouped data set with what? Frequencies. Are we there? So now for the ungrouped data set with frequencies, what do we say? We will say let x1, x2, x3 up to what? Xn be n data entries in a data set. The n data entries in a data set having respective frequencies having respective frequencies F1, F2, F3 up to Fn. Full stop. The arithmetic mean denoted by X bar will be given as X bar equals summation Fi xi from I equals 1 to n all over summation Fi from I equals 1 to n. So, what are we saying? If your data set is ungrouped and it has frequencies, your arithmetic mean, which was formerly computed with x1 plus x2 plus x3 all over n, up to xn all over n, will now accommodate frequencies, and this is the formula for computing it. I'm going to show you how to use that. Then comes the third and final group. Group 3. Please, somebody should tell me something. When we discussed group frequency table, I told you that our xi's for a group frequency table will be called what? In a group frequency table, what are your xi's? They are what? Class marks. So, in a group frequency table, your xi's are no more data entries. They are rather what? Class marks. The average of each class interval. So, I want to be sure that you understand the language. So, I'm going to use that language here. Arithmetic mean for grouped frequency for group data set. Arithmetic mean for group data set. Now, let x1, x2, x3 up to xn be n class marks. Do you see the difference? Be n class marks in a group frequency table. In a group frequency table, having F1, F2, F3 up to Fn frequencies. Then, the arithmetic mean X bar will be calculated using the formula X bar equals summation I equals 1 to n Fi xi all over summation Fi from I equals 1 to n. Now, if you look at this formula and this formula, you will think they are the same. Indeed, they are the same. But the difference between these two, even as they look alike, they look exactly the same, is that this one here, the xi's are data entries. This one here, the xi's are what? Class marks. Is it clear? Good. Different methods may be used to obtain the arithmetic mean. Different methods may be used to obtain the arithmetic mean under certain circumstances. Full stop. These methods are: 1. Assumed mean method. 2. Coded factor method. We shall quickly look at these two methods. Now let me explain something, everybody. Please listen. Do you know that something can happen in this class? Let's assume, I think it is correct if I say Daniel is your class rep, right? Daniel is your class rep. Good. Now, I know that there is somebody also that may be acting as an assistant to Daniel. And please listen. What prompts an assumed mean method to be used? What prompts a coded factor method to be used? Is what I want to explain. So, please listen carefully. On a certain day we came to class and Daniel was not in class. But we needed information that every other department seemed to be getting, and Daniel would have gotten if he were to be around. Daniel could not get the information across to us, so we were suffering information-wise because we were information deficient. So, we now say enough is enough. Daniel is sick, or Daniel, God forbid, is not available. However, because of his unavailability, we should not suffer. Why don't we bring up somebody who will assume the role of Daniel? In other words, that person is not the class rep. He is not the value produced by the mean. He is rather who we would call an assumed mean. So, this method here, called the assumed mean method, is a method that works on that principle of using someone from amongst the data entries or someone from outside the data entries to act like the class rep, which he is not. Why would that be? When you start, if I give you a problem now with 5, 6, 7, 9, 10 to operate on as values in a data set, if 5 has a frequency of 4, you just know that fx will be 5 times 4, is it not so? And 5 times 4 is a simple value to multiply, which will give us what? 20. But what if they now start giving you your data entries in thousands, like 1972, and the frequency of 1972 as a value in that data set is 1,500,000 and something thousand? You would need to multiply 2 of them, which will still give you what? A larger value, is it not so? This assumed mean method and the coded factor method is a data entry reduction method that makes you reduce data entry to something manageable. Then after your computation, you now reverse the process. It will still give you, without approximation, the exact thing you got as your arithmetic mean. Is it clear? So, that is the method we want to discuss. Assumed mean method, coded factor method. So, let's write the assumed mean method. The assumed mean method works with what is called, is called an assumed mean. The assumed mean is a value within the data set, or from outside the data set, which helps to reduce the data entries to something smaller, to aid easy computation. Full stop. I'm going to say let A be an assumed mean. Are you listening? Let A be what? An assumed mean. The guy we choose to represent Daniel, to assume the role of the class rep when Daniel is not what? Around. That is the person we are calling A. Let all deviations from A, from xi by A be what? Di. Now take note, why is x carrying I? As you move through the data set, this guy will be different from this guy. This guy will be different from this guy. Everybody will be different, you know so? And even as everybody is different, I am not putting I to A because A is what? Constant. A is the guy we say, for instance, we can say, oh boy, stand up. You will represent Daniel while he's not around. Do you understand me? Now, take note of one thing, sit down. Do you know that Daniel may be a very nice class rep and we all love him because he has some attributes that make him suitable for the role of a class rep. Number one, he is easily accessible. You can meet Daniel and say, oh, boy, what did happen? Class go today. You say, no class. He won't get angry. Whether man or woman, you can call him anytime. You can chat him up. He will respond. You understand me? And he controls his temper very well. So we now like Daniel for all these attributes. All of a sudden, we now choose the assumed mean, the person that will replace Daniel or not replace, to stand in place of what? Daniel. Now, this guy, if Daniel was equal to all of us, in the sense that the gap between each of us and Daniel is so small. Now that we have chosen a guy to represent Daniel, we want to know the gap. Do you see it? So, those gaps are what we are calling what? Di. If the guy we have chosen to represent Daniel is the assumed mean, there will be gaps between each of us and the guys, you know so? Now, the gaps will be changing, meaning that Di will be equal to Xi minus what? A. Do you understand me? Di will be what? Xi minus what? A. Again, Di is changing because the gap between that guy and each of us, we are the Xi's. The guy we have chosen, that guy is the A. This is the gap. So the gaps are changing, we are changing, but one thing remains constant. The person we chose is just one person. Now, at this point, we have just established a relationship that Di is equal to Xi minus A. Make Xi your subject of formula. This symbol means implication. This statement implies that if I make Xi my subject of formula, what would I have? Xi means that minus A will leave Xi, and this will be what? Di plus what? A. Is it not so? Now, think about it. A young girl sits down in front of the mirror. Boys don't do that stuff. So when a woman wakes up from sleep, there's saliva here, there's saliva there. She doesn't look as pretty as we see her in school. So she now has an assumption that today, maybe today is the day before my birthday, she looks at the mirror. I want to look like this. And When she wakes up in the morning, she wakes up as xi. But the makeup she wants to do, she wants to look like x bar. Do you understand me? You know, makeup implies that she'll be putting things on her face, the one they call foundation, the one they call whatsoever. They put those things, put. She now resembles who she would like to what? Resemble. So, this is the girl, or this is you, but this is how you want to look like. Okay? Please listen. So, the first thing we are going to do, please look up. You would put, the one I want you to do is the one of the one without frequencies. So, I'm going to use Fi to multiply both sides. If you use Fi to multiply xi, what are you going to have? Fi xi. Use Fi to multiply this other side. It will be Fi times di plus a. Is it also? Good. Next, Fi xi will be equal to, open this bracket with Fi. It will be Fi times di, which will be what? Fi di plus Fi times a, which is what? AFI or FIA, whichever one. Okay? When the girl gets to this stage, she still looks at the mirror. This is not the same as what? It is not the same as X bar. Is it clear? So, she does the next thing. The next thing is to take the summation of both sides. So, she will take the summation of this side from I equals 1 to n, Fi xi, and she will take the summation of this other side in bracket Fidi plus what? AFI. The sigma in mathematics is what we call a linear operator. See, the sigma is a linear operator. It has one power of opening up what? Brackets. So, if that sigma on this side, you know it is sigma into bracket, this plus that, is it not so? The sigma will take each of them. So, I'm going to come over and say this implies that summation Fi xi from I equals 1 to n will be equal to summation from I equals 1 to n of what? Fi di, do you see it? Plus that same summation now. Do you know what that summation will do? When the sigma as a linear operator meets a constant, a is a constant and Fi is what? A variable. It will bring out that constant and take on the variable. Let me show you why. Look up, everybody. See, if I tell you 5x plus 5y plus 5z, what is common to the three of them? 5. Is it not the same thing as saying 5 into bracket x plus y plus z? Is the same, right? Now, let me change this y to x2. Let me change this y, this one to x1. Let me change this to what? X3. This will change to x2, x1, and what? X3. Is it not so? Then, if I want to write this one shorthand, what would I put? I equals 1 to what? 3, xi. Is it not so? So, when the sigma takes on this one that is a constant, it will push it out just like this and take on the what? The variable. So, at the end of the day, this is what you are going to get. Now, at this point in time again, the girl will look at the mirror. Am I looking at this guy or looking like this guy? She is not yet there. So she still needs one more makeup to apply. What she will now do is to divide both sides by summation Fi. So if she divides the left-hand side by summation Fi, she will need to divide the right-hand side by what? Summation Fi. Now, when she divides both sides by summation Fi, there is a simple principle in algebra that A plus B over C is A over C plus B over C. They have a common denominator. So, if she applies that principle here, it will mean that what she has obtained is from I equals 1 to n, Fidi plus, that is over what? The common denominator is summation Fi, is it not so? And this is A summation Fi from I equals 1 to what? N. All over summation Fi from I equals 1 to N. This one here will cancel this one. This is just like saying 5A over A. A will cancel A. Is it not so? So that one will cancel that one. And we will be left with summation from I equals 1 to N Fi di all over summation from I equals 1 to N Fi plus what is left? A. Now, on this side, what do you have? Fi xi I equals 1 to N all over summation Fi from I equals 1 to N. Is it not so? At this point in time, the girl will look at the mirror again. Do I now look like X bar? The answer is a big yes. We have defined this, remember, as what? X bar. Go back and check what your X bar is. Your X bar was defined as what? Summation Fi xi all over what? Summation Fi. This is the point she says I can now go out. Thank you very much.